Hey there, y'all. Today we're going to look at the Unit 2, Chapter 2 review on relations and functions. Like Unit 1, we're going to go over the different objective statements and talk about the key things to know for this test. And so in 2.1, we talked about functions and continuity. And our two objectives were that we would determine whether functions are one-to-one and onto, and also if they were discrete or continuous. And so let's look at 2.1. And so in this section, remember, we talked about the definitions of one-to-one and also onto. Remember that one-to-one, every x has exactly one y, right? Whereas onto, just every element of the range has an element of the domain. And remember that a function, going back to Algebra 1, that every x has one y. Remember the different intricacies of that definition. So then we talked about domain and range. And remember that domain and range is the x values and the y values of the function. And we talked about later in this section about being discrete or continuous. And remember, discrete is a function that has gaps or breaks, and so we're looking at those individual points. Or continuous is a function that has a continuous piece. And we talk about what type of functions that would necessitate. In section 2, we talked about linearity and symmetry. And our objectives there were to identify linear and nonlinear functions by examining equations or graphs, and to determine whether graphs or functions have line or point symmetry. And in that section, remember that linear functions are going to have an x and a y that are not multiplied together. They're not raised to a power. The x and the y are not in powers, and the x and the y are not in the denominator of fractions. And so we can look at what type of functions those would be. And then looking at the graph, we can tell, well, do the points make a line or do they not make a line? And remember, symmetry, we're looking for a line. So for line symmetry, we're looking for a line where I'll be able to reflect this left and right across the coordinate plane, or across the line of symmetry. And it doesn't have to be an axis. It could be any vertical line. And then with point symmetry, remember, we're looking for a single point on the graph that I would be able to take it and rotate it 180 degrees, and I end up with the same picture rotated about that point. Remember, we talked about using a shadow or a fake coordinate plane to understand how far points were away on both sides of that potential point of symmetry. In section 3, we talked about extrema and end behavior, and we want to look at the extrema and end behavior of graphs and functions. And remember, that is where we're going to talk about as x goes to a certain value. So as x goes to negative infinity, where's the y going? Positive infinity or negative infinity? As the x goes to positive infinity, where's the y going? Up to positive infinity or down to negative infinity? And remember, it could go to a specific value, like if we're looking at an exponential graph, we could talk about it coming out to a specific value as we go towards that asymptote. And so remember, when we have nonlinear functions, we can talk about the end behavior on that as well. And so that was the big thing in section 3. We also talk about relative maxes and relative mins and the turning points. And remember, those two are going to be at the same places. And so remember, we talked about how when we get to the bottom of a graph, when we get to that valley, that is a relative min. It could be the minimum of the entire function, but it is at least a relative min for that section. And when we get to the hills, we're talking about relative maxes, or again, potentially the maximum of the entire function. And so again, we look at graphs to figure out those relative mins and relative maxes. In section 4, we talked about sketching graphs of functions, and we were going to use the key features of functions to be able to sketch graphs of linear and nonlinear functions. And when we talk about that in section 4, what we're looking at is being able to identify our x-intercepts, our y-intercepts, points at where it is positive above the x-axis or negative below the x-axis, where it's increasing, so the slope between the points or the rate of change between points is positive, or decreasing, where the slope or rate of change between 2 points is negative. And then, of course, the end behavior that we talked about in section 3, what's it doing as we go out towards negative and positive infinity in x? Where is it going? To positive infinity in y or negative infinity in y. Okay? And so we use all of that information to be able to graph pictures. Again, is it linear? Or as we looked in example B, is it nonlinear? We talk about continuity. If a function is continuous, it's connected with smooth lines or curves. We have our extremas of mins and maxes, and of course any potential lines of symmetry to know, am I going to be symmetric or do I have pieces going in opposite directions? Remember that we flipped section 6 and section 5 in this, and so we're going to look at section 6 next on transformations of functions. And that's being able to identify the effects of the function when we have f of x plus k or f of x minus h. And then we also looked at with an a either in front of the function or inside with the x, and also what a negative involved with those would mean. And so remember that at the bottom of the notes here, so we talked about parent graph and transformations and translations, but if we go all the way down to the bottom of these notes, we have that table right here that is summing up everything we talked about in this section. So horizontal translation, what's going to make it move to the right, what's going to make it move to the left, what makes it move up or down when we talk about that k value, and where's that a value? Is it inside the grouping symbol affecting the x? And remember that if it's inside affecting the x, your x is doing what to you? It's lying to you. And so remember, if it's inside, we're going to be moving horizontally, but in a different manner than what would present to itself normally. And then remember that the dilation factor is also either inside or outside, depending on which it affects. So in section 5, our objectives were that we graph and analyze piecewise step and absolute value functions. Remember, we looked at 3 different types of functions in that section, and we took a few days to look at that. But remember that piecewise function, we've just got different pieces graphed or different pieces given to us, and evaluating that, remember that we're going to be plugging in a value based on the domain, which x value am I plugging in, and that will determine which piece of the function I'm able to substitute in for. And so like our graph here, here's our 2 pieces. Remember that we're going to draw a line at that x value where we go from one piece to the next, and we either need to have dots or circles depending on what is happening. Okay? And so then we talked about step functions, and remember step functions are those greatest integer functions where it kind of looks like a ladder going up or a stairway going up. And so remember that we can write a function, and this is when we need stuff to round to the next value, right? So remember that if where our circles and dots are, and that's based on where we're rounding, right? So if I'm at an integer, I'm not going to round anywhere because I'm already at that integer. But it's the moment I step past that integer to 1.01 from 1, that 1.01 will now round up to the next integer, which is 2. Don't forget about those on that type function. And then the last type was the absolute value functions. And so remember that is our v's. And so remember we have slopes of both pieces that are going to be opposites of one another. So if this piece has a slope of 5, this piece has a slope of -5. And so remember that that can also be translated up, down, left, right. We can stretch it, we can shrink it, we can do what we need to do to make that function happen. And finally, section 7, we looked at how to solve equations by graphing. We want to know how we can find the x and y intercepts of a function, and to be able to solve equations by examining the graphs of related functions. And remember, we talked about how in this section, the biggest thing is first remembering how to graph our different types of functions. We've talked about linear functions before, Algebra 1, right? Middle school math. We've talked about quadratic functions in 8th grade and Algebra 1. We've talked about piecewise and step functions and absolute value functions all in this unit. And so all of those would be fair game to be able to find the x-intercepts and the y-intercepts of graphs, and also be able to use them as we look down at example 3 on how to write out a function for the related function. Remember, we want to solve it for 0. And when we do that, we can replace the 0 with y, graph that now 2-variable equation on the coordinate plane, and find the x-intercepts, which become the zeros of the function or the roots of an equation. And that's where our solutions are found. So that is the entire chapter. Again, big things from this chapter. Know how to deal with graphs, know where it's going, know your critical values, your turning points, your intercepts. All those are important to this unit. So if you've got questions, make sure you put them in the Google form so we can talk about that during the review, and then we'll be getting ready for this test. So I'll catch y'all next time, and I hope y'all have a good one.